Hi, everybody. Welcome to the last part of this week's lecture. This is on Mars, and it also finishes out our study of the individual terrestrial planets in the solar system. Now, we are going to spend some time, like we said before, on terrestrial planets, looking at their surfaces and all the different things that affect what their surfaces look like, what we can learn from looking at different surfaces of different planets about, say, presence of atmospheres or presence of water, etc. So we're going to do some comparative planetology, but that'll be next week. Okay, we're going to start with just thinking about how, life on Mars has been this fascination of many people. For instance, Percival Lowell was the first person to suggest that there were these canals, meaning water canals, that were, according to him, built by Martians to help their dying society, right? Because what he looked and saw were these sort of scratch-like things, turned out not to be water canals, but his whole idea was, of course, that these were water canals built by aliens who lived on Mars, and these were also described in the stories by H.G. Wells. You might have seen the movie in 2005, it was a while ago for you, but I think it was Tom Cruise, War of the Worlds. That's an H.G. Wells story. That also was a radio program in the 30s that was so realistic. So it was made as this. It was the War of the Worlds, but it was it was like a newscast. So it was this sort of fake news story. They weren't trying to fool anybody. They were just making a radio story. And a lot of people believed them, and there was, kind of mass hysteria, people trying to leave, the area. I think it was in New Jersey where they were supposed to have landed. So it really has captured the imagination for a long time. And of course, you probably know this, but of all the planets, Mars is the one we have been to the most, all right? And by we, I mean robots, right? Not us personally. No man has stepped on the foot of on the soil of Mars. I hope someday, soon-ish, this will happen. So I thought we'd start with just a brief history of all the Mars exploration that has happened, with all the robots we've sent, and some of them have landed, some of them have just circled the planet. It's why we know so much about Mars. Okay, so let me get to this video. Okay, I gotta go back. Sorry about that. Okay. Let me get this going here.
In the 3rd millennia BCE, early astronomers from Mesopotamia mapped the stars, giving names to constellations and planets. They called the red planet Nergal, after their god of war. For the ancient Greeks, the celestial body was likewise their god of war, Ares. The ancient Romans gave it the name we use today, Mars. Over 1,000 years later, in 1609, Galileo used the newly invented telescope to get a closer look at the red planet. By the 19th century, advanced telescopes allowed astronomers to see details of the planet's surface. They saw what came to be thought of as vast canals, surely evidence of civilization. People became fascinated with the idea of life on Mars. And then, in 1964, we did something those Mesopotamian astronomers could only have dreamed of. We sent a craft, the Mariner 4, on a 228-day journey to orbit the red planet. Viking 1 touched down on July 20th, 1975, and sent back the first images from the Martian surface. On NBC Nightly News, astronomer Carl Sagan reacted to this unprecedented feat with a characteristically broad perspective.
I think it gets to something very deep in human nature, the will to explore, the lust for discovery. The curiosity, I think, is something built extremely deeply into us. It's an essential part of our nature, and the Earth is all explored. Here is a way with inexpensive machines of extending ourselves beyond our planet. And I'm just delighted with the whole business.
We've since landed 7 more objects on Mars to study topography and geography, and in the process, learned that those canals, which incited such a frenzy, turned out to be nothing more than an optical illusion. NASA landed the InSight lander on Mars in November 2018 to finally explore the interior structure of the 4.5 billion-year-old planet and give us a greater understanding of all planetary evolution, including that of our own. The next step may have been inevitable since those ancient Mesopotamians first began to look up. From NASA to the United Arab Emirates to the private company SpaceX, several disparate plans are underway for us to make the greatest journey in our history as a species. Will we get there? Carl Sagan thought so.
Maybe we're on Mars because of the magnificent science that can be done there. The gates of the wonder world are opening in our time. Or maybe we're on Mars because we have to be, because there is a deep nomadic impulse built into us by the evolutionary process. We come, after all, from hunter-gatherers, and for 99.9% of our tenure on Earth, we've been wanderers, and the next place to wander to is Mars. But whatever the reason you're on Mars is, I'm glad you're there, and I wish I was with you.
So, great overview. And also there is another lander that is due to land on Mars February 21st of 2021. That's Perseverance. It's on its way to Mars right now. There's a nice little countdown that you can watch on the NASA site. It's also called Mars Rover, I think Mars Rover 2020. So really we keep investigating Mars. That last one, InSight, we're going to talk about a little bit because that was the one that that brought a seismometer, right? So, or seismograph, to look at the vibrations of Mars. Remember, that's how we know a lot about the interior of planets. Certainly the Earth, we know that. We know a lot about the interior of the Earth because of earthquakes and these, vibrations of the Earth. So that's given us some insight into Mars that it certainly hasn't all been processed yet. Okay, so what are its planetary properties? Well, Mars is very cold and dry, right? It's pretty small. It's kind of amazing how small it is. It's about half the radius, but it has about 1/10 of the mass of Earth. And it does not have a strong magnetic field. We saw how important magnetic fields are previously. We talked about how the fact that Venus doesn't have a strong magnetic field contributed to water going away in its atmosphere, leaving its atmosphere, and contributed to its, very hostile, the beginnings of its very hostile environment. Its year is about, twice our year. In length, but its day is about the same as ours, 24 hours, 37 minutes long. So that's pretty interesting. And you can see it has a lot of surface features, which we're going to get into. So there are really interesting surface features. One of them, I think, is very fascinating. Not that they aren't all fascinating, but the biggest volcano in the solar system is found on Mars, and that's Olympus Mons. It covers an area the size of Arizona, and it's higher than Everest by like 3 times, basically. And it's, produced in the past. It's not active now. Produced lavas just very similar to the ones produced on Earth. And you can see sort of several, views of it. Look at that thing. It's just enormous. And here's a little sort of a plateau close-up of it. This is an artist rendition. Okay. There's these canyons. I think this is really, really interesting. So the big canyon called Valles Marineris, here is an actual picture, and here's sort of a computer-generated model. And if you go up here, you can kind of see it. It's kind of like a big scar across the face of Mars. And I think it's really interesting because it was formed in some ways like the Grand Canyon was formed. So we know the Grand Canyon was formed by a river just cutting through the rock over eons. So some of that definitely happened. There was water, people think, because we'll get to that, on Mars in the past. And that some of the features that you see in Valles Marineris were caused by water flow. Now, it's too big to be carved just by water. So people think there was this sort of cracking of the surface that caused this to form as well. But there's lots of evidence of water. So let's take a look at a video for that.
The Grand Canyon is a unique and spectacular landform. There is nothing quite like it anywhere else on Earth. But if we cast our gaze to more distant horizons, we can find another similarly amazing location. The planet Mars has its own Grand Canyon, Valles Marineris, and it is interesting to compare Mars's canyon with ours. The full sweep of the grandeur of Earth's Grand Canyon can be seen very well by looking down from space. Here we see the canyon's winding path stretching from Lake Powell in the east to Lake Mead in the west. Similarly, in this view from NASA's Viking orbiter, we can see Valles Marineris reaching across vast stretches of the Martian terrain. Earth's Grand Canyon is actually a large network of interconnecting canyons. The same can be said for Valles Marineris on Mars. The deep cut and steep walls of the Grand Canyon expose many layers of geological deposits, reaching way back into time. Similarly, Valles Marineris displays numerous layers, including lake floor sedimentary deposits laid down in Mars's distant watery past. The deep cut made by the Colorado River has been significantly widened by numerous landslides along the Grand Canyon's steep walls. Surprise Valley is nearly filled with debris from the largest landslide deposit in the Grand Canyon, containing over a cubic mile of displaced material. Nearby, Deer Creek is cutting a new gorge as it bypasses landslide blockage. Zooming down toward Ius Labis in Valles Marineris, we see a titanic landslide deposit measuring over 30 miles across and stretching 25 miles out across the floor of the valley. In places along the northwestern edge of the Grand Canyon, we find volcanic cinder cones from which flows of lava cascaded over the canyon walls into the gorge of the Colorado River. These flows built temporary dams that created lakes that partially filled the canyon in its past. To the northwest of Valles Marineris, we also find volcanoes, the giant Tharsis Shield volcanoes, which played key roles in the formation of the canyon. These mountains include Olympus Mons, the greatest volcano in the solar system, standing 3 times the height of Mount Everest, and with a base 370 miles across. Flowing water played a critical role in the Grand Canyon's formation, with the Colorado River cutting the canyon's deep gorge. Flowing water also played a role in Valles Marineris. This color-coded height map shows where channels of water flowed out of the canyon into a great bay. While they have many similarities, the two canyons also have significant differences. The Grand Canyon was formed primarily by erosion through the cutting power of the Colorado River. While water altered the landscape of Valles Marineris, this feature is far too big to have been cut by water. It is a great tectonic fracture of the planet's crust. Size is another key difference between the two canyons. Valles Marineris is far larger. If it were on Earth, it could stretch from the U.S.'s east coast to west coast, with many of its smaller subcanyons still dwarfing our Grand Canyon. Another difference is that Earth's Grand Canyon now hosts over 6 million visitors per year. Valles Marineris is still waiting to receive its first tourists. Perhaps you will be one of them.
It'd be great to visit that, wouldn't it? Anyway, amazing how big that is, and its deepest part is 7 kilometers deep, whereas the Grand Canyon's deepest part is only 2 kilometers. So it is the biggest canyon that we know of. So very interesting, and very interesting that water played such a role in that formation. Let me go to the slideshow. Play from current slide. There we go. All right. So Mars has ice caps, polar ice caps, like the Earth does. Now the Earth has polar ice caps that do not retreat meaning they don't melt off every summer, right? They stay, they're permanent. Now global warming is changing that, unfortunately, and it would be very bad for the planet if those ice caps melted every summer the way they do on Mars. They're mainly CO2, but they do have water that we think there's water ice also in those ice caps. We know water is present, and it's been found by the Phoenix lander at the northern pole. So that's really good. It's actually been found. Anyway, so really interesting. They come and go. They're really marked features on the surface. Pretty amazing. Okay. Now, Mars does have an atmosphere. It's very thin compared to Earth. Most of it's CO2. There is Martian weather. So there's little clouds that can form. You can see on this diagram here, there's these thin CO2 ice clouds, and you can have some thin water clouds as well. There are dust storms and fogs and winds. But they are even though the wind speeds and so these dust storms can get very, very high, like 400 miles per hour. Dust storm could be dangerous for clogging equipment, but if you were in 400 mile an hour winds on Mars, you would not really even feel it. So I don't know if you've ever seen the movie The Martian. So the whole premise of that book, a lot of the science in that book is fantastic. Like most of the science is fantastic. But the whole story starts with a windstorm that knocks over a bunch of things and strands one of the astronauts. And that just wouldn't happen. There's just not enough pressure, not enough atmosphere to actually do that. And of course this is not breathable atmosphere for us. And even if it was thick enough not to be very close to a vacuum. Okay. Now Mars has moons. Unlike Venus doesn't have any moons, Mercury doesn't have any moons. But they're really kind of odd. So they're these little asteroid-looking like things. People aren't really sure how they were, how they came to be moons of Mars. People thought maybe they could be captured, but that really is unlikely. We talked about how that's unlikely for things to be captured. It's really hard orbital dynamics for that to work. And the interesting thing is that Phobos is basically spiraling into the planet. So it's Phobos and Deimos. And Phobos is just spiraling into the planet. About 10 million years, it's going to crash into the surface of the planet. So it does not have a stable orbit. So nobody really understands what's up with these guys. But they're so little that they have not become spherical. So really interesting little moons. Okay. So we talked about this a little when we talked about the Valles Marineris and how it formed. We really have a lot of evidence that there was water flow in the early history of Mars. And you might see if you read the book here, these little pellets thing, they've called them blueberries, quote unquote. They're actually not blueberries. They're probably hematite, which if you ever played with hematite, it's really beautiful black mineral that, if you went into like a rock store, they shine them up and they're really pretty. And, if you ever collected rocks as a kid, they're a fun thing to have. And really, they're associated with the presence of water. That's really how they form. And they're all over the place on Mars, inside the soil, on top of rocks, as you can see in this picture. And small amounts of subsurface ice were found by the Phoenix lander. So that's really pretty amazing. There's really not any conclusive evidence that there was like large bodies of water. You saw in that elevation map that we looked at when we were looking at the Valles Marineris video, that the idea is that there was a large bay of water that fed into. but there's no conclusive evidence that there was, big seas or, big lakes or bays. So we don't really know. And hopefully the newest Mars rover will shed some more light on that. But it is, we know that there was some water flow. We just don't know, like I said, big lakes or big oceans or anything like that. It wasn't like, a water world or anything. At least we don't have any conclusive evidence that that was the case. But it certainly was very different. Now there's evidence of subsurface water here in these two pictures. You can see there's a picture, one taken, I think it was about 6 years apart, and you can see there's some flow that's still happening now. So the subsurface sort of melt water that's causing these little, rivulets kind of things happening in this picture. Still happening. Now let's look at this. This is you have to kind of dig into this picture. Let's look at the history, and we're going to look at a few different things in this picture. So we have the core temperature, we have the surface temperature, we have the atmospheric pressure, the magnetic field strength, and habitability according to humans, right? So if you look, about 4.5 billion years ago, which is when the solar system was formed, you can see that, it was highly molten, the core, very hot, and that there was, that we had a pretty high temperature above 0 degrees, so above freezing, and we had thick atmosphere, lots of magnetic field, which is great. Now, of course, the habitability was low then because it was a really inhospitable time in Mars's history. Sort of noxious gases, too hot, etc. Now, as time went on, though, right, we had the atmosphere decrease a little bit, but if you notice, the temperature went down in the core, temperature went down on the surface, and the habitability went up. So the period that we think that water flow was happening in Mars was probably a very, very different planet, was this Noachian period, which is between 4 and 3.5 billion years ago, so not that long after it formed. And then things kind of went downhill from there, right? So we got drier, water vapor, atmosphere evaporated, so it becomes a very thin atmosphere. As you can see here, the atmospheric pressure really starts to go down into its current level, which is very thin and low now. And this is the Amazonian is the current era in Mars. But things really did change a lot in the history of Mars from what we know. Okay, so again, here's in this slide, I'm not going to go through this slide in detail, but it's a nice little summary of these different periods for you to look at. Okay, let's try a question. Pause your video.